Thank you. So I just wanted to kind of touch on some of the points that we just kind of mentioned, but distill. So the cache, when it comes to actually implementing it, it can be on either spinning platter hard drive or SSD, and that largely comes down to the different use case. So generally, since cache serves to ingest the data that's being uploaded to it before it goes out to the network, then that means that the speed of the cache just needs to at least match the speed at which data might be coming into you or might be coming into the relayer. So if you're on just like a 100 megabit line or something, you probably don't need NVMe SSD cache just because that's not going to be where the bottleneck is. The bottleneck is your upload speed. But as you start getting into multi-gig territory, you might find that one or two spinning drives just not enough to be able to saturate all the internet that you're paying for. So that's where SSD kind of comes in. And the relayer doesn't really care what it is. There's nowhere that you have to say what type it is. The relayer is going to use the cache as to the maximum that it's able to, and it all looks the same to it, just ones and zeros. So I'm going to share a screen here. This should be familiar. This is our favorite XNS.tech docs. I think all of you should know. I don't know why Spotify was doing that. So this is the Linux Relayer UI. This should be familiar if you've gone through our training videos. And just wanted to highlight scrolling down to where the Docker Compose YML file is. So this is the kind of basic boilerplate Docker compose.yml. This is what names the Docker image, gives it its name, allocates volumes, the ports, and the env file. If you have gone through the certs and kind of certificates and domain name and proxy, if you've gone through that whole section before, then your compose.yml will look a little bit more complicated than this, but this is kind of reduced to its simplest form. We can see here that in the volumes section, we have the basic within the container. This is just known as /relayer. Anything after the colon, this is the name within the container. So we can see here, there's relayer and there's relayer meta. The meta is the cache folder. So this volume section is kind of matching a real mount on the file system to a mount within the container. So this is creating on the spot relayer data if it doesn't already exist, and this is where most of the relayer stuff is going. That would be everything that's covered in a backup, which we'll get into later in this call. But we can see here that commented out, so that's the meaning of the hashtag. Commented out, we have the second line where you can mount a disk. So typically external disks or extra disks are mounted in a Linux file system as like on the mount path, and then we just do a dummy like disk 2, and let's say we have a relayer cache on it, then that will be mounted within the container as relayer meta. So we don't want to change anything on this side of the colon, but on the left side, that's where you would actually be dealing with it in the file system. So what this allows you to do with just kind of two basic lines, if you don't specify the relayer meta, then it'll just go in the first volume. But if you want to branch it out, that's why I included it here, even though it's commented out. So just by removing that pound sign and customizing this to a real path, maybe on another hard drive, on a NVMe that you are just dedicating to the cache, there's nothing else running on it, then that would be where you do that. So then it's just a matter of like normal, saving the file and then Docker compose up-d force recreate, and that makes the container with the new mount and able to use the cache. So that's the mechanics of how you actually allocate to the drive. Another thing that's a consideration is you may have noticed that here there's no setting where you decide how big the cache is. This isn't done in the volume section. This is actually done within the container. So over here, I have a relayer setup. Here in the UI, I've allocated it 250 gigabytes. We have a little bit of intelligence as well on, so we can see the available space on the system, the used space, and then I guess the raw disk as well. So I believe this is just pulling the intelligence straight from that. Um, there it is. That is just assuming it's this disk that the main relayer is mounted on. Unfortunately, at this moment, we don't have. So if you have other mounts, like just for the relayer cache, they don't show up differently in this space. But you will essentially allocate the cache size. You can size it up and you can size it down. Big asterisk. So I think if I tried allocating this to more size than I actually even have, it will give me an alert before I even hit save. It'll say your cache configuration exceeds your available disk space. That's just a good little kind of sanity check and sanity warning. Of course, we do give you the power to do everything, which includes hurting yourself. So I think if you really wanted to, you could hit save, and you could blow through the ceiling of the disk space, and that would not be good. You can end up with corrupted cache that way. So that's why it's in red letters. We don't totally stop you from doing that, but it would not be a good idea either. Then if I size down from 250 to just regular 50, it gives you another warning that you are reducing your cache size. I would not recommend doing this if you have your cache currently full. So I can see my pending uploads is currently empty. So that means everything that's in my cache has already drained out to the network. So there wouldn't be much consequence to if I were to do this, because there isn't anything that hasn't uploaded yet to the network that's in the cache. But that is just a consideration, that if you are going from if you're sizing down essentially, make sure that everything in the cache has uploaded out to the net, um, so that you don't experience data loss. But we give you a warning for that too. So that's just a little bit of intelligence either direction to remind you and give you kind of a sanity check as you're changing around in the cache. But in general, I think the these UI or these docs pages should cover pretty well. Yeah, like here in just the setup introduction, we even cover there that you can do either like an NVMe main disk, and for really big setups, you might want to consider like an enterprise hard drive cache. That will be particularly important when we start getting into some of the things that Ken mentioned of not just having an upload cache, but also kind of a download cache. So
One thing I guess to note is that as soon as if a file's been evicted from the cache and then you access it again and it pulls it from the network, then that file again follows the first in, first out. So that file will sit back in the cache again and won't get evicted again until everything else ahead of it has been. So just by simply grabbing file back off the network, it starts that process of first in, first out again.
yeah, and the eviction, that just means like obviously there's a finite amount of space in the cache. We can't have all the files in there. At least if you use your relayer a lot and are sending a lot of data through it, you can't. So the eviction just means when something that's been in the cache for a while gets bumped out to make room for something new. Is that right?
That's right. And yeah, I guess once the cache, like if there's a lot of data still waiting to be uploaded to the network, host IO does actually have some smarts in there that are configurable. It's kind of like a slow back off. So what it'll actually do is tell your client that's uploading the cache is getting full, and it'll start accepting the packets a little bit slower. So what you might notice is that if your cache is over 80% used and waiting to be uploaded, the connections coming from the client side will actually slow down a little bit to try to give the cache some time to clear itself by uploading to the network before it accepts more data.
So we do have in the docs that in general the cache should be as large as the largest single data set that is uploaded in a session. The idea or the thinking there is just that regardless of what your upload speed out to the internet is, most local networks, like their LAN speed is like full gigabit or full 10 gigabit, something like that, regardless of what your speed out to the rest of the internet is. So the thinking there is that if you have your relayer on the same network, if you have it locally, then you could transfer at that full gigabit or full 10 gigabit speed and just get your backup off your machine and into the relayer so that the relayer could then upload it over a longer period of time if maybe your internet speed is ultimately limiting. So that's when we talk about how having a local relayer is kind of more efficient, and that's closer to the vision of how they're kind of meant to be used. And while hosted relayers or cloud relayers, like if you just give a customer an endpoint to use, there's still advantages to that, and obviously reasons why you might want to do that over regular cloud. But when we talk about how having it on premise is kind of the most native way and the most efficient way, this is what we're kind of speaking to. That's why we suggest that it's at least as large as the largest data set. But if you can reasonably have more space than that, then there's advantages to that too. So